Okay. So now let us continue here. Okay, again, I have put those results here. So sine of minus x is minus sine x. Okay, so the minus will come in the front. Now, whether you provide negative inputs or positive inputs, cos function is going to give the same values. Again, guys, try to understand. I am not saying cos function is always going to give you positive values. All I'm saying is it is going to give you the same values. Okay, so for example, let me give you an example. Okay. So let's say I have cos of pi by 3. Okay, so cos of pi by 3 is half, and then cos of minus pi by 3 is again half. But suppose if I take, let's say, cos of, you can check this, 2 pi by 3. Okay, so 2 pi by 3 will push you into the second quadrant. So there the value is minus half. Now, if you, instead of going in the counterclockwise direction, if I go minus 2 pi by 3, I'll get minus half. Okay, so sometimes there is a feeling that the cos is just giving always positive values. I'm not saying that. Okay, the input, whether it is positive or negative, you are going to get the same values. The values that you get can be positive, negative. Okay. That is one. And then we have seen that cos of x plus y is cos x into cos y minus sin x into sin y. Okay, so now using this, we want to prove that cos of x minus y is cos x into cos y plus sin x into sin y. So let's write what we have just proved. Okay, so cos of x plus y is maybe I'll do one thing. Okay, I'll just write this straight away, and then I'll tell you what I have in my mind. Okay. Okay. Now we have this. Because here we are working with variables x and y, instead of, we're going to use this result. Okay, so this result is important for us. So instead of x and y, I'll convert this into a and b. Okay, so my x becomes a, and
so
then
it's cos x cos y minus sin x sin y.
Yes. Okay, so I think this is something that is familiar with all students coming from 10th class, right? So we'll go back to that. But here, there is a good reason why your textbook actually uses x and y, because these are functions. So in till 10th class, I think we were using a and b. There we always had this idea that these angles are part of a right angle triangle. Okay, but we are actually going beyond. So your textbook is like clearly doing a fantastic job. It is saying that, okay, the reason I'm using x and y is it's a general notation. Wherever you have like inputs, we generally use x, and then outputs generally y. But to understand, maybe we can go back to a and b, but still treat a and b as your input values. So if I write it this way, okay.
So it's minus on the top in the.
Acha, here. Oh, here.
Yeah.
That is what you're saying. Yes,
Yeah.
thank you, beta. Thank you. Yeah.
No problem.
Yes. I do that. I do those mistakes. Okay. So now instead of x, I'm writing a here. So I have cos of a plus b is cos a, cos b minus, okay, so sin a and then sin b. Now what I want you to do is, I don't want you to look at this anymore. Okay, so cos of, I want you to look at it, but for the moment, so don't worry about this. Okay. Now, to understand why this is true, okay, so we want to prove that this is cos of x minus y is cos x into cos y plus sin x into sin y. What you need to do is simply look at the left hand side. X minus y, I can write it as x plus, let's say, minus y as an input. Okay, so I'm just writing it this way. So if I do that, you can see that your A, we use a different thing. So your A is your x, and your B is your minus y. Can I say that? Your A is x, and then B is minus y. So I can use cos of A plus B now. So cos of A plus B is cos A. So I'll get simply cos x. And then cos of B is cos of minus y. Okay. Minus sin of A is sin x. And then sin B is sin of minus y. Okay. Now you need to pay attention to these things. So cos of minus y and then sin of minus y. So cos x is just borrowed. Now cos of minus y is simply cos y. Okay, minus sin x, but sin of minus y is sin y with a minus sign upfront. Okay, so maybe I'm using a bracket here to put that minus sign there. So sin of minus y. Okay, so I think that is okay. Now you have minus into minus. Okay, so these two things. Minus into minus will make it positive. So you'll get cos x into cos y plus sin x into sin y. So we know this result, and then we know sin of minus x is minus sin x, and then cos of minus x is cos x. So we are using those results to prove this one. Okay. So again, I'll pause here for a minute. So understand, so make sure you understand this. Okay, so if there are no questions, we'll move to the next result. So here, again, I mean, I'm not a big fan of like developing memory techniques, but you can observe a pattern here. Okay, so if you have a plus here, I think you will have a minus here. So yeah, maybe a good pattern to keep in mind. So if you have a minus here in the, let's say, input side, on the output side, you have a plus here. Okay, the right hand. Okay, so now let's prove this one. So cos of pi by 2 minus x is sin x. Now here again, I'm going to take this result. Okay, so whatever we have here, so this result, cos of x minus y is cos x into cos y plus sin x into sin y. I'm going to write using a and b. Okay, so let me do that here. So what do we have? Cos of a minus b is equal to cos a into cos b plus sin a into sin. Now take a look at a. Okay, so if I put a as pi by 2 and then b as x. Okay, so a becomes pi by 2 and then b becomes x. Then we can write this as cos of pi by 2 minus x. Okay, so understand this. So I'm just taking pi by 2 as a and x as b. Okay, so we're just substituting. So now the right side should also be equal if you substitute the corresponding values for a and b. So let's do that. Okay. So this becomes cos of pi by 2 and cos x plus sin pi by 2 and sin x. Now, what is cos pi by 2? Cos pi by 2 is simply 0. And then whatever cos x gives you doesn't matter. You're multiplying by 0. So I think that will become a 0. Okay, so this first term will become 0. Plus sin pi by 2 is 1 multiplied by sin x. So you end up having 0 plus sin x. So which will give you sin x. Okay, so sin cos of pi by 2 minus x is sin x. Okay, so I will pause here for a minute. Let me know, guys. Okay, so you guys are okay here?
Yes, sir. Yeah. It's okay.
So let's use a unit circle to understand the same thing. Let me put a unit circle here. Okay, again, I am getting used to this. The writing tool is good, but I have basic skills. Okay, so let's say that is the unit circle. Let me put that is our x-axis and y-axis. Okay. Okay. Now we can actually try and understand this using the unit circle. Okay, so cos of pi by 2 minus x we are doing, right? So what can we do here? So where will be, suppose if I take x as positive, okay, so x is a positive number, let's say x is a positive number. So if I do minus x indicates that I'm actually traveling in the clockwise direction to some point, let's say A here. Okay, so this angle okay, so this is basically minus x. Now plus pi by 2. Okay, so minus x plus pi by 2. What will this do? You need to understand this. Okay, so minus x, you're rotating clockwise by x units. And then if you have plus pi by 2, you are moving in the counterclockwise direction by 90 degrees. So if you move counterclockwise direction 90 degrees, you can take a line which is perpendicular to OA. So let me call that B. Now this is 90 degrees. So if this is 90 degrees, what will happen? This angle is going to be pi by 2 minus x. Okay, so this is going to be pi by 2 minus x. Now let's look at the B. Okay, so let's look at this triangle. Okay, so OB, maybe I'll call this M. Now, what are the coordinates of B? So if you take the coordinates of B, the angle relative to the reference line x-axis is pi by 2 minus x now. Okay, so this will the x coordinate will be cos of pi by 2 minus x, and y coordinate will be sine of pi by 2 minus x. Okay, so forget about that sine of pi by 2 minus x. Now pay attention to this. Can I say cos of pi by 2 minus x is going to give you the value OM? Okay, so this is going to give you value OM. So let me write that. Okay, so cos of pi by 2 minus x is going to give me OM. Now in this right angle triangle OBM, we'll use the basic ideas from let's say 10th class. Okay, now this angle is 90, so this angle will be x. Now if I use the definition of sine x now in that triangle, do you see that you are going to get OM by OB? Okay, opposite side, opposite to x, this OM by OB. Now by definition we are working, by convention we are working with a unit circle, so OB is 1. So that means OM by 1 is OM. Now do you see these two are equal? Okay, so you can prove this using your unit circle. Okay. Is everyone okay here?
Yeah, sir.
Yeah. Okay. So let's just move on. Okay. Now the same thing. I mean, you can either use a unit circle or maybe the manipulation that we are trying to do. Okay. So here, what we can do is left hand side. Pay attention here. So if because I know only cos of pi by 2 minus x. Now, if you
Minus x.
look at the result here, so we have cos of pi by 2 minus x. So let's use that, okay? Cos of pi by 2 minus x we know. Okay, so I think I'll write that as a. Okay, so cos of pi by 2 minus a is sine a. Okay, we'll go slow here. Okay, so because we'll be like interchanging variables, so that can sometimes be mind bending. Okay, so we have this. Okay, now what we want to do here is, let's say a is pi by 2 minus x. Okay, so this is what we are taking it here. So a itself is pi by 2 minus x. Okay, so a is pi by 2 minus x. So now substitute that here. Okay, so if I substitute, so I have cos of
Sir, if a is pi by 2 minus x, so we're writing pi by 2 minus pi by 2 plus x?
yes, that is what I'm proposing. This is what is actually done in your textbook also. Okay, so a is pi by 2 minus x. So we are taking pi by 2 minus, that's exactly what we are doing. Okay, so pi by 2 minus x. And then right side you have sine of pi by 2 minus x. Okay, so what we have on the left hand side here went to the right hand side. Do you see that? So what you have on the right hand side came to the left hand side now. So pi by 2 minus pi by 2 will disappear. On the left hand side you have cos x, and the right hand side I have sine of pi by 2 minus x.
Okay, I understood why we did that now.
You
Yeah.
understand?
Yeah, okay.
Again, so we can also use our unit circle. Okay, so now we have this result proved. But again, I mean, if we go back to our unit circle, okay, so let's look at the unit circle again here. Now, if I look at this right angle triangle OBM, your y coordinate is sine of pi by 2 minus x, right? So let's write that down here. Okay, so I'm writing at the left upper corner. So from that triangle, sine of pi by 2 minus x, by definition, it will be what? Bm by OB, but OB is 1, so we don't worry about writing it. Okay, so that's basically Bm. Okay, so this is what we have now. Okay, so this is your sine of pi by 2 minus x, the y coordinate. Now look at cos of x. Okay, now if you're taking cos of x, then that Bm becomes the adjacent side, right? So Bm becomes adjacent side. So again, you will write Bm by OB. So these two are equal. So that means these two are equal. Are we okay? So the idea is, if you have an input x, if you are taking it away from pi by 2, okay. So sine pi by 2 minus x is going to give you cos x, and then cos pi by 2 minus x is going to give you sin x. Kind of complementary. So again, I'll pause here for a minute. Let me know if you are okay. Ask me if you have any questions. Okay, so I am assuming these things are okay. So we'll move on. Okay, so now sine of x plus y is equal to sine x into cos y plus cos x into sine y. Okay, so this is what we will try to look at now. So what can we do here? I think, do you think I should give you some time so that you will try using whatever we have proved? Guys, I think I should
I'll
give,
try, sir.
yeah. So I'll pause. So use whatever we have seen and then try to prove this. So, okay, so now do one thing, okay? So let's look at the previous few results, okay? Maybe sine is becoming cos is becoming sine, right? So that is when you have cos of pi by 2 minus x. Maybe then let's write, but let's not write a x x. वो थोड़ा सा मुश्किल पड़ता है, right? So what we'll do is we'll use a, or maybe this time let us use theta को लाते हैं. So cos of pi by 2 minus theta. So instead of x, I have theta. So this is sine x. And then similarly, sine of pi by 2 minus theta is cos x. Okay. Now, if you look at the first result that we have here.
So it will be sine theta and cos theta, right? Then
Yeah.
We-
Oh, I thank
we
you.
can't have a new variable. X.
Yes. This x is because mind has that x now. So it overpowers. So that is theta. Yes. And then here also it overpowered. See, sometimes we don't know what we are doing. This is an example. It should be theta. Yeah. Thank you, beta. So that should be theta. Okay. So now here, let's look at this. Take a look at this x plus y. Okay, so this x plus y is an angle. Okay, so like theta. X plus y is an angle like theta. So why not consider, okay, so let theta be x plus y. So in that case, I have sine theta, right? So sine theta, I can write it as cos of pi by 2 minus theta. So that means I can write sine of, I'm going from right hand side to the left hand side. Okay, so that is what we're trying to do. So we're going from right hand side to left hand side. So sine of x plus y is cos of pi by 2 minus x plus y. Okay, so this is what we're doing. And here, because we just want, let's say, sine, cos, and then with just x or y as the input. So what we can do is we know these identities with pi by 2. So we can combine these two guys. Okay, so pi by 2 and then x we are bringing together, or you can actually alternatively use pi by 2 and then y. It doesn't matter. So here we are saying I have cos of pi by 2 minus x and minus y. Now again, you could have taken pi by 2 minus y minus x, doesn't matter. Now look at this. Now what result can we use here? We can use cos of a minus b. So what is cos of a minus b? It is cos a, cos b plus sine a, sine b. Now, but what is my a and b? So my a will be pi by 2 minus x. My b will be y. Okay, are you able to follow this? So this pi by 2 minus x will become a and y is b. So the right hand side, whatever we have in the right hand side will become. So now cos of a is pi by 2 minus x, b is y. So the right hand side, we have cos of pi by 2 minus x, and then I have cos y plus sine of pi by 2 minus x, and then sine y. Okay, now what does this give on the right hand side? Cos of pi by 2 minus x will become sine x. Okay, so here, see, look at this one. So sine pi by 2 minus theta will be, sorry, here. Okay, so cos pi by 2 minus theta will be sine theta. So similarly, cos pi by 2 minus x is sine x. And then we have cos pi plus, again, sine pi by 2 minus x. So we can use this. Pi by 2 minus theta is cos theta. So we have cos x, whatever it is, cos x and sine y. And the left hand side, we know that it is sine of x plus y. Okay, so I think, yeah, that's it. Okay, so again, I'll pause here for a minute. Let me know if you have understood this. Okay, so I'll pause here for a minute. Okay, so can I say we are okay here? Sudhanya, you're okay? Sudhanya,
Yes, sir, I understood.
understood? Okay. Okay, so we will continue. Okay. Okay, so now I think this is easy to prove. Okay, so what we can do is we can just prove this using the previous result. Okay, so what do we have? Instead of x plus y, again, I will use, let's say, a plus b. Let's say sine of a plus b will be sine a, okay, and then multiplied by cos b plus cos a sine b. Okay, so it will take a few, let's say, a few days to get your heads around this. You need to practice also. So here what we are doing is the left hand side, I'm writing it as sine of x plus of minus y. Okay, so my a is x, my b is minus y. Okay, so that is what we are trying to do. So if I use that result which we just obtained, I can say sine x and then cos of minus y plus cos x and then sine of minus y. And then here cos of minus y is just cos y. So I'll get sine x into cos y plus cos x. But here sine of minus y will be sine y with a minus sign up front. So minus sine y. And you know that this will come here. So you get sine x into cos y minus cos x into sine. Okay, so that is the result. Okay, so that is what we are looking at. Okay, so I hope this is okay. Again, I'll pause a minute here. Let me know if you have any questions. Yeah, Harsha. Questions?
Nothing, sir.
Okay, good. So let's move on. Okay, so this, I think I will give you a minute to work on this. Okay, so you can either use whatever we have proved, or maybe remember we use that unit circle. If you want to use unit circle and then use the definitions of cos and sine, you can use that and then try to prove. I'll give 2 or 3 minutes to work on this on your own. Okay. Okay, so let's discuss this thing. So you can actually use cos of, what is it? You have cos of, what is that? So cos of this pi by 2 minus theta is sine theta, right? So we can start with this. So here, if I look at the left hand side, I want to write using a minus, not a plus, okay? So, but you can easily manipulate that, right? So you can say cos of you can write this as pi by 2 minus, instead of taking plus x, I'm going to take minus x. Okay, so this is now exactly like this. Cos of pi by 2 minus theta. So where theta is basically minus x. So then what do you get? You get sine theta, which is sine of minus x. But you know, sine of minus x is minus sine x. So that is how we get this result. Okay. So cos pi by 2 plus x will be, it's almost the previous result, but yeah, whenever you are going towards sine, there is a minus sign here. Okay. Okay, I think we'll do one thing. So let us understand this using our unit circle also. Okay, so it's a good idea to understand. Okay, so let's use our unit circle. Okay, so we start with an input x, let's say. Again, guys, I'm starting with a point in the first quadrant, but there is no need. You can actually show that this is true, whether you start in second, third, or fourth quadrant. Okay. So I'm starting with a point on the first quadrant. So this is x. So because positive x, we're going in the counterclockwise direction, and then from there we are going 90. Okay, so take a perpendicular line. So this is 90, and then you get this point B. Okay, now the point B has an x coordinate, which is cos of pi by 2 plus x, because you can see that with the reference line, okay, our x-axis, you have turned in the counterclockwise direction by x plus pi by 2. Now, what are the coordinates of B? I think I'll write it here. I need some space. So the coordinates of B will be cos of pi by 2 minus x, and then sine, plus. So sine of pi by 2 plus x. Okay, so that pi by 2 plus x we will use it a little later. Now, drop a perpendicular from B to x-axis. Okay, so let's call that B. Now, what is cos of pi by 2 plus x? Okay, so how can I get cos of pi by 2 plus x? Pi by 2 plus x is simply the x coordinate. You guys remember? Just the x coordinate. So let me highlight that. Okay, make this point O. So this is our x coordinate. Okay, OM. But we have to be careful here. Okay, so I cannot just write OM. Okay, so OM is a number. Okay, but x coordinate is negative here. So I need to put a minus sign and then write OM. Okay, I hope you guys understand. And then after that, what we can do, we are trying to show that this OM is actually sin x. Now, how can you show that OM is sin x? Let's drop a perpendicular from A as well. Okay, so let's drop a perpendicular from A. So let's call that N. Now, if you look at, this is X, this is 90. So what can be this angle? So this will be 90 minus X. So this is going to be X. Okay, so this angle right here is 90 minus X. So this angle is X. And similarly, this angle is 90 minus X. Now you have this rule, right? RHS. Okay, so there is a right angle. Okay, and then hypotenuse is basically our radius. And then one of these sides should be equal. Okay, now which side is equal? Okay, so how do we show which side is equal? So can I say that this is equal to this? Because are we okay here?
Which one, sir?
This side is equal to this. Can I show that? Do you think it follows right angle is there. Hypotenuse is anyway your unit circle radius, so that is equal. Can you see any other sides equal? Or can you say that these are actually congruent? Can you say that?
BM and AN.
BM and
AN.
okay. So how can we say? We can just use our maybe trig identities, right? So if I look at triangle, let me write that. So triangle maybe OBM, एक ले लेते, and then triangle, let me say OBM लिया ना, then let me take AON. Okay, so in these two triangles, if I use the definition of, let's say, sine x, so definition of sine x will give me OM by OB, and then in this triangle AON, it will give me AN by OA. But we know OB and OA are equal. So these are equal anyway. So then that tells us that OM is equal to AN. Are we okay? So OM is equal to AN. So let me highlight those sides. OM, okay, so this one is equal to this one. That is what we want to prove anyway, right? So OM is equal to AN. And then, but here AN and OM are just the positive values, the numbers, the distance. So this minus sign will come up front. So cos of pi by 2 plus x will become minus AN, which is AN is sin x. So minus sin x are there. Are we okay here?
Yeah, sir.
Yeah, I think you can either use whatever we have derived, or you can take the help of your unit circle. But yeah, when you take the help of unit circle, the general idea is you are trying to look at the congruency of two triangles, or let's say you're trying to use the definitions of the right angle triangle, the trig ratios with the help of a right angle triangle. Okay, so if there are no questions, let us move on. Okay, so if you have understood that, then this should be easy. So here we will just utilize sine of pi by 2 minus theta is cos theta. So the left hand side I can write it as sine of pi by 2. That plus I'm going to take it as minus x. Okay.
So we can also do a sine of a plus b also.
You can do sine of a plus b also.
All of them just require 2 steps. So either way,
either way is fine. So even that is good. Okay, so that is also good, because one term will have cos pi by 2, and that disappears. That is also acceptable. Yes. So here we are using cos of minus x, and then this will become just cos x. So as you rightly pointed out, yeah, either you use that or this requires only one step. Yes. Okay. Okay, so let's look at few more results. Again, one suggestion is, I mean, you should try it yourselves also, because I find these identities, to remember these identities, I normally think in terms of unit circle. Okay, so that helps me. Okay, so you should see if you can use the unit circle, because if you just go by the algebra, sometimes they don't stick with us, the results, because sometimes they may, but I think try to visualize in terms of the unit circle also. Over a period, it should be easy to remember. Okay, as you apply them in various settings, I think this should be easier. Okay, so now cos of pi minus x is minus cos x. Again, here you can prove this in several ways. Okay, so one of the ways will be we just use cos of a minus b. Okay, so if I use cos of a minus b, what do we have? It is cos a cos b plus sin a sin b. So a will be pi and then b is x. Okay, so my left hand side will become, so cos a, which is cos pi, and then cos x plus sin a sin pi and sin x. Now we know cos pi is -1 into cos x, and then sin pi is 0, so 0 into sin x. So this gives us minus cos x. Okay, so this is one way. But again, I mean, if you think in terms of the unit circle, you can clearly see what is going on actually. Okay, so let's put the unit circle and then understand. Okay, so this time let me remove this fill. Okay, so if I take the unit circle, so OX. Now pi radian. So if you move in the counterclockwise direction, so pi radians, and after that, what you are trying to do? You're trying to go minus x. So minus x means you're moving in the clockwise direction. So if you do that, okay, so I'll place let's say 2 points. So I'm taking a horizontal line. Okay, so if I move, yeah, I think that's okay. So if I move in the clockwise direction minus x, so I'm going to come to this point. So let's call that A. Now, if I just go x in the counterclockwise direction, okay, so if I just go x in the counterclockwise direction, I'll come to this point. So let's call that B. So we're okay with these things. Now,
Yeah.
draw perpendiculars from A and B. Okay, so if we draw perpendiculars from A and B, let's call that M and N. You can clearly see that these two triangles are actually congruent. Right? The angle is X. Yeah, one is positive, the other is negative. That is okay. And then OA and OB are equal, and then it's a right angle triangle. Okay, so these are definitely congruent. I think there's no question about it. Okay, so we can write, but they're definitely congruent. Now, the cosine function is going to give us the y values, right? The cosine function gives us, sorry, what did I say? Guys, erase that from your memory. Cosine function gives y values or x values?
X values.
X values. Yeah, that was a mistake. So cosine function gives x values. So when I say cos of pi minus x, okay, so pi is this angle, and then I'm reversing by minus x, so I'll reach this point. So cos of pi minus x gives us the x value of this point A, x coordinate of point A. Okay, so cos of pi minus x, that is sine of pi minus x, that is the y value. Okay, we will use that a little later. So we are getting this value OM, but we are in the second quadrant, so we will get minus OM, right? So you get minus OM. Now cos x will be what? ON. Cos x will be ON. Now magnitude wise, OM and then ON, they are equal. Okay, it's just that when you do cos of pi minus x, you are in the second quadrant. Okay, again, it depends on the x value. Okay, I'm assuming that x is acute. Okay, so x is acute, it is between 0 and 90. So that is why after moving pi radians in the counterclockwise direction, if you move x radians in the clockwise direction, you are ending in the second quadrant. But if x is more than 90, you might end in the first quadrant, or maybe you end up in the third quadrant, sorry, fourth quadrant or third quadrant. But it doesn't matter. You can actually verify this, that you'll always get the same result. So cos of pi minus x is minus cos x. Okay, you can see here OM is equal to ON, but since you are in the second quadrant, you need to take it with a minus sign. Okay, so that is why you will get cos of pi minus x as minus cos x. Okay, I'll pause here for a minute. Let me know if you have any questions. And I suggest that you actually try this. Okay, so instead of moving only by an acute angle, you should try and move it by, let's say, an angle which is greater than 90. And then from here you do that. And then you should see that you're actually getting the same result. Okay, so that would be good practice. Then it helps you understand these better. Okay, so if there are no questions, let's move on. Okay, so now here sine of pi minus x is equal to sine x. So we can actually use the same, let's say, I'll just copy this, okay? We copy this. Put it here, okay. So now what is going to be our sine of pi minus x? Okay, so for these 2 points A and B, we're going to get the y values. Now here we have just established the fact that these two are OMA and then ONB, they are congruent triangles. So, and I have drawn a horizontal line parallel to x-axis. So it clearly makes these two equal, AM and then BN equal. And both are positive 2. Okay, so that is why sine pi minus x is simply sine x. And I think this is very easy to follow. Or if you want, you can use that sine of A minus B as sine A, sine B minus cos A, cos B. So here, if you put A as pi and then B as x, so the left-hand side will become sine of A, so which is sine pi, and then sine x minus cos of A, which is cos pi, cos x. Again, I'm making a mistake. This is a huge mistake. Guys, do you see? I got carried away. Guys, do you see the huge mistake? This is cos B, okay, not sine. Okay, this is sine. So this is cos B. This is sine B. Okay, where do I need to correct this? So I need to correct it here. I need to correct it. So this will be cos x, and this will be sine x. And then this is anyway 0, okay, because sine pi is 0. And then cos pi, we know it is minus 1. So that minus and then minus will become plus, and then you will end up having sine x. Yeah. So it doesn't matter. I think the other way that you can use is, if you want, you can actually use pi. You can write it as, so pi by 2 plus pi by 2 minus x. If you want, you can do even this way. Okay, then we've already seen, right? Sine pi by 2 plus x. So what is that sine pi by 2 plus x? You will get cos x. Okay, so we have this result. So you can use this also, but your x will be this pi by 2 minus x. So that is something that we need to keep in mind. Okay, so this will become cos of pi by 2 minus x, but again, cos of pi by 2 minus x will become sin x. So yeah, whatever feels comfortable, you can select that and then show. So again, I'll pause here for a minute. Let me know if you have any questions. Okay, so let's move on. Okay, so cos pi plus x will be minus cos x. Again, let's use the unit circle to understand this. This X, Y, O. Okay. Now, first we are moving, let's say pi radians, and then plus X. So we are continuing our rotation in the counterclockwise direction. Again, I am assuming that my X is acute. Okay, so it's between 0 and pi by 2. Guys, did I write pi by 2 last time? 0 and pi by 2 acute. Sometimes, yeah, I think I wrote 90 degrees here. I'm using pi by 2. Okay. So if I just move in the counterclockwise direction, so let's say I'm coming till here. Let's take that point as A. So this is X. Now, your cos X. Okay, so cos X will be, let's look at it this way. Now, can I claim that if I extend this, this will be X? Can you see this, guys? Your vertically opposite angles will be equal, right?
Yeah, sir.
Right. So
Yes, sir.
then this point will be B. Now you can clearly see if I drop a perpendicular. Okay, so this is N and then this is M, this perpendicular. Now cos of pi plus X is going to give you OM, but with a negative sign. Okay, so in this unit circle, OA and then OB are equal. So this guy will become minus OM. Now what is OM? OM is actually ON. Again, these two triangles are actually congruent. Okay, easy to show that these two are congruent. And then cos X, if you look at the triangle OBN, you get ON. So this is basically minus ON. Now that gives you minus cos X. Okay. So the result is okay. Again, you have the other alternatives. You can try and split pi into pi by 2 plus pi by 2. So that is 1. Or you can just use cos of A plus B, which is cos A, cos B minus sin A, sin. Okay, so those two approaches are also okay. Okay, I'll pause here for a minute. Let me know if you have any questions. Okay. So let's continue here. So I have sine pi by 2 plus X. So we can do the same thing. So let's copy this unit circle there. Sorry, what am I doing? I want to copy tool, select tool, sorry. Let's take this. So now I'm liking this notability. Okay, so now let's look at this. Okay. Now sine is going to give you the y values. But when you actually take a look at sine pi plus x, you're going to get a y value which is negative. Okay, so you're going to get a y value which is negative. Again, if AM is taken as positive, this quantity is actually minus AN. But when you take sine x, you're getting BN. Okay, so sine x is, this is just BN. Now, do you see? I can actually write sine of pi plus x will be minus BN. Okay, so that will make this a negative value. We're okay. I think this is understandable. Guys, just let me know if you're okay with this.
Yes, sir. Okay.
This is okay. Om?
Yes.
Okay. Sudhanya, you're also okay?
Yes, sir.
Okay, great. So let's move on here. And then again, so this also should be easily understood. Again, we have all these three options, but I think I'll go with the unit circle. Okay. So if you look at the unit circle, okay, I think that's kind of an ellipse, but that is okay. So X and then Y. So you're going 2 pi radians. So 2 pi radians is like you start from OA and then come back here all the way. So that is your 2 pi radians. And then minus X. So if you do minus X, moving in the clockwise direction, so to this point A. So this is your minus x. Now you can clearly see that if you drop a perpendicular from A, so n, so cos of 2 pi minus x is this distance OM. And the same thing can be obtained if I have an angle in the first quadrant. Okay, so let's say B and then drop a perpendicular. We have seen that this is plus x. And then you see you will get cos x and cos of minus x. And again, we have seen this, right? If you add 2 pi, it is basically, the left hand side is basically cos of minus x anyway. Okay, then we know whether you supply minus x or x, the cos function is going to give you the same values. So that is why this result goes. Okay, I think this is easy to understand. Okay, so this is simply cos x. So I think let's move forward. Now maybe I might need this circle. I'll just copy it. Okay, so 2 pi minus x will be what? It is going to give us the y values. But when you look at the y values, for 2 pi minus x, the y values are negative. Okay, so y values are negative. Okay, why am I erasing? So y values are negative. But for sine x, they're positive. But you know that these two triangles are congruent. So we can easily see that this is minus, I think, an. And this is, sorry, am, bm. And then you know that these two are equal. Okay, and alternatively, you have the other approaches also. So I am hoping this is also easy to follow. Okay. Or the other one is, if you add 2 pi to any input, okay, the sign output will not change. So this is as good as sine of minus x. And then when you do sine of minus x, you know, minus sign goes up. So minus sine x. That is also acceptable. Okay. Okay. So, okay, now we are getting into tan. Okay. Again, guys, I think for this, what I will do is I'll pause for a few minutes. I want you to try on your own. Okay. So try this for maybe 2 or 3 minutes. Try proving it on your own, and then we'll discuss. Okay, so you're able to make it, guys?
No, sir.
It's not hard. Okay, see. How can you express tan in terms of sine and then cos?
Sine by cos.
Sine by cos, right? So that's all you need. So tan of x plus y is sine of x plus y by cos of x plus y, right? Now, if you go back, we have these results, right? Sine of x plus y and then cos of x plus y. Now, what is sine of x plus y? So sine x. Yeah, it will take a few days of practice to write this correctly. Now you saw me, I also write incorrectly sometimes. So it will take practice. Okay, so sine x cos phi. So don't worry about that. And plus cos x sine phi. And then in the denominator, what do you have? You have cos x, cos y.
Sine y, sir.
No, I think cos x cos y minus sin x sin y. Yeah, cos ke liye you first have both cos operations and then sin operations. Okay.
Okay, sir. Yeah.
Now what you do is you divide both sides by
Cos x cos y.
very good. You can divide by you don't want this cos y here. So you divide by I want to highlight. So yes, that is correct. So you divide by cos y. But again, here I don't want this. So what we can do is divide both numerator and denominator by cos x into cos y. Okay, so cos x into cos y. So what will happen here? Let me write it here. So that is equal to, so sin x. Guys, I think when you are showing this in the school exam or homework, please write them on separate lines. Don't do this. Okay. So this is just for us to understand. So dividing this by cos x into cos y. And then यहाँ पर I have cos x sin y and then divide by cos x into cos y. And then because I'm dividing the numerator, I should do the same thing for the denominator, right? So I'll do the same thing for the denominator. So cos x cos y by cos x cos y minus sin x sin y and cos x cos y. I think we are done here. So you can see that you can happily ignore these two. Ignore these two. So in the numerator you get sin by cos, so tan x, and then sin by cos y, so you get tan y. This is extremely useful result. You will use this, and then here I think 1 minus you have tan x and then tan y. Okay, so that proves the result. And why am I saying that x plus y, they cannot be odd multiples of pi by 2 because of this reason. Okay, so if you look at here, we are dividing by your your tan x is actually sin x by cos x. So you can't divide by 0. So when are your cos values 0, when the input is an odd multiple of pi by 2. So even here, okay. So even here, okay. So that is why none of these angles must be odd multiples of pi by 2. Okay, so I will pause here for a minute. Let me know if you have any questions. Okay, so I'm assuming this is okay. Okay, now this is what, once you get that, what you can do is you can do the same kind of manipulation that we were doing, or you can start by writing, let's say, sin by cos. So your tan of x minus y will be sin of x minus y by cos of x minus y. So this is sin x cos y minus cos x sin y, and then in the denominator you have cos x cos y. So this will become plus here. Okay, so keep that in mind. So sin x sin y, and then what do we do here? The same thing. You divide by cos x and cos y. So sin x cos y divided by cos x cos y. And then here I have cos x sin y divided by cos x cos y and cos x cos y by cos x cos y, and the second term also gets divided sin x sin y by cos x cos y. And in the numerator, what do you have? You have these, let's say cos y ये disappear हो जाएगा. And you will end up having tan x, this time minus tan y. And in the denominator, you have 1 plus tan x tan. There is actually symmetry, okay, guys. So if you look at the symmetry, na, when you have x plus y, you look at this. Okay, so in the numerator, you have plus, and in the denominator, you have minus. So now when you have minus, in the numerator, you have minus, and then here you have plus. You're taking a difference, and then you are taking a product here. Okay. Again, I'll pause here for a minute. Let me know if you have any questions. Okay, I think this should be okay. And then again, you understand why there is a restriction, right? So you cannot divide by 0, and then these are the angles where your cosine function becomes 0. And you don't want that to happen. Okay, so now if you have understood previous one, so this is easy. Okay, so again, this you can do it in multiple ways. So one of the ways is, you know, that cot and tan, they are reciprocals of one another. So maybe you can start with that. Okay, so cot x plus y is 1 by tan of x plus y. And then we have just proved what tan of x plus y is equal to. So 1 over, in the denominator I can write this as tan x plus tan y divided by 1 minus tan x tan y. So I think this will move to upstairs. So this will become 1 minus, so tan x tan y by tan x plus tan y. But again, you have only cot on the right hand side. So again, you use the reciprocal idea. So tan x can be written as 1 by cot x, 1 by cot x. And tan y is 1 by cot y, then divided by 1 by cot x plus 1 by cot. Now, if you look at the numerator, this is your LCM. Okay, and then so you can write your numerator as cot x, cot y minus 1 by, okay, I know that cot x into cot y is also there in the denominator, so I'm actually ignoring that. So I hope that is okay. So you can just write, replace here, so cot y plus cot x. Okay, so, and then this is okay. Guys, again, I'll pause here for a minute. Let me know if you understand this or you agree with this. So is everyone okay? Harsha, you're okay with this?
Yeah, sir. Okay.
Okay, so Om, Sudhanya.
Yes, sir.
Okay, so
Yes, sir, got it.
you got it, right? Yeah, we'll do let's say problems based on this. Okay, so we'll do problems based on this. Okay, so let's move on. Okay, so cot of x minus y. I think we can pretty much do the same thing here. So your cot of x minus y, maybe we can do one thing. Okay, if you want, we can use the previous result, but I think let's use the reciprocal idea. So tan of x minus y. So what do we have? 1 of, so this will be tan x minus tan y divided by 1 plus tan x and then tan y. So send this to the upstairs and then we'll have 1 plus tan x. Okay, so tan y by tan x minus tan y. And then again, convert your tans into cots. So you will have 1 plus 1 by cot x into 1 by cot y divided by 1 by cot x minus 1 by cot. So and then again, I'm going to ignore these. Okay, so I'm not going to write these in the denominator of numerator and the denominator. I hope you understand what I mean. So I'll just write cot x into cot y plus 1. But in the exam, I think it's better you write that. Okay, so one more step. Okay, guys, you need to squeeze in one more step for clarity. Okay, so that proves our result. Okay, so again, I'll pause here for a minute. Let me know if you have any questions. Okay, again, like I was saying, immediately you will not recall whenever you need them. It will take a little bit of practice. Okay, but again, you can't recall, there's nothing to worry. Okay, so you can go back, refresh, and then keep working on problems. So you will get them eventually. Okay, so then what do we have now? Yeah, we have a few more interesting things. Okay, so we will have to prove cost. I think these are all identical. Okay, so these are all identical. Here we are taking cos 2x is the input. Okay, so cos 2x, we need to show that it is cos square x minus sin square x. And this is actually easy. So let's look at our cos of a plus b. Okay, so what is cos of a plus b? Cos of a plus b is cos a cos b minus sin a sin. Now here, if you put, okay, so if you put a is equal to b is equal to x, suppose. Okay, so a, b are equal to x. So if you do that, your a plus b is 2x, right? A plus b is 2x. And then cos a into cos b is basically cos x into cos x, right? So cos x is getting multiplied with cos x. You will write it as cos square x. And then sin a into sin b is sin x into sin x. So you will write that as sin square. So cos 2x is cos square x minus sin square x. Guys, this is extremely useful. Okay, so when we do physics, sometimes to solve problems, we have to integrate. Okay, so we'll see. Don't worry about what this integration is. But yeah, that is something that we'll have to do. So there, this cos 2x routinely comes. Okay. Now, so this is done. Okay, so this is done. Now, how do you get the second step? Okay, now look at one of our identities. I think the earlier identities was sin square x plus cos square x is 1, right? So I can take this sin square x and then write it as 1 minus cos square x. So here, wherever you have sin square x, I am just writing it as 1 minus cos square x. So this cos square x is anyway there, minus 1 minus cos square x. So if you do that, I think you will get this. Okay, but instead of that, if you, let's say, eliminate cos square x. So you could do that, right, from here. So cos square x is 1 minus sin square x. So eliminate that. So write it here. So cos square x is 1 minus sin square x minus sin square x. So that will give you this result. Okay. And how do we get the last one? So you have this cos square x minus sin square x, right? So any idea? I think I'll do one thing. Okay. So I want you guys to prove this. Okay. So let's say I'll give you a minute. So the last one, how can we get from here? So, okay. So we have cos 2x. Cos 2x is cos square x minus sin square x. So how can I go from here to this result? Okay, so you have a minute or two to think about it, and then we'll discuss this. Okay, so okay, if you divide by cos, but you are getting something new, right? You're altering, isn't it? So if you divide by cos, you are actually altering it. You get the point?
Yes.
Okay, so you need to think of something else. But you have that. I'll give a hint. Okay, so what you need to divide this is there on the screen. Okay, is there on the screen. So think about it. I'll wait for a minute. Okay, so did you find what you're looking for? Okay, let's look at this. Let's look at this. It is on the screen. Okay, so let's look at this. What is this? Sin square x plus cos square x is 1.
Yeah.
So if you divide by sine square x plus cos square x, it's as good as dividing by 1. Right?
Yes, sir.
So that shouldn't change the value, right? So instead of dividing by 1, what I'm saying is I'll divide by sine square x plus cos square x. Are you getting this? Sine square x plus
Yes.
cos square x. Oh, now you divide both numerator and denominator by cos square x. So if you now divide both numerator by cos square x, so the first will be cos square x by cos square x is 1, minus you will get sine square x by cos square x. And then you can do the same thing for the denominator. So sine square x plus cos square x plus 1, and then you get this result. Are we okay here? So that will become 1 minus tan square x by 1 plus tan square x. Okay, so this is also useful later on. Now, guys, you need to understand that whatever trigonometry that you learn, right now it might look like manipulation here and there, but try to understand the concepts. Later on, you will need them when you do calculus. Okay, so when you do calculus, that's very, very important. It's like prerequisite. It's a mandatory thing that you should understand before you move calculus. Okay, so let's look at. Okay, now let's look at this one. Okay. So we don't want the, let's say, x to be n pi plus pi by 2. So we will understand why that is true. And then let's see how we can prove this. And here again, you can use one of the results that we proved. So sine A plus B is sine A cos B plus cos A sine B. And then let's take A equal to B equal to X. So what will happen? The left hand side will be sine x plus x, so that will be 2x. So that is done. Okay, so that is done. That is done. On the right hand side, what do you have on the right hand side? You will write sin x cos x plus cos x sin x. So if you multiply, I mean, here it's the commutative rule is applicable, right? Sin x into cos x is equal to cos x into sin x. So you will write that as 2 sin x cos x. And how do we get the last line? Again, you divide here by 1. So dividing by 1 is as good as dividing by sine square x plus cos square x. So you divide by sine square x plus cos square x. And then you divide numerator and denominator both by cos square x. Okay, so both by cos square x. Okay, so sine square x by cos square x. Okay, what am I writing? Yeah, plus cos square x by cos square x, and then you will get this. Okay, so I hope you understand this. Again, these are also extremely useful. The sine 2x is like 2 sin x cos x is again routinely used. In fact, even before learning trigonometry, you might use this in one of the physics classes. Okay, so let's. What is the thing? Can we do one more guess? How are we doing here?